In today's video, we're going to be taking a look at MechMat, the software suite provided by Actus Potentia to use for mechanics and materials problems. Specifically, we're going to be looking at the combined loading section of it, and we're going to be looking at a non-circular section for our problem. So for this problem, we have a similar piece that you've seen in previous videos. Now that will be the L bracket you see there with the 40 and 30 pound forces applied at the tips. It is 3 inches wide and 4 inches tall. And we're going to be taking a look at the cut line there at the bottom of the orange section. Now this cut is taken 2 inches from the 30 and 40 pound forces in green at the bottom, which makes our R vector 0 inches in the I direction, 0 inches in the J direction, and 2 inches in the K direction. As for our force vector, we have 0 pounds in the I direction, minus 30 pounds in the J direction, and 40 pounds in the K direction. As for our cross-section, we see that we have an I-beam cross-section. It has a 1 inch wide flange that is 0.125 inches thick. We have a 0.75 inch tall web that is 0.25 inches thick. The bottom flange mirrors the top flange, so they are equal there. There's no difference between the two. And now that we have the general idea of what we're working with, we can get started setting up the problem. To get started with MechMat, once you open the program, you'll see this screen. Simply press the Start button to get started. Now it'll bring up this screen, which highlights all of the different things MechMat is capable of helping you with. So for instance, that would be stress-strain transformations, axial loading, torsional loading, beam bending, buckling, combined loading, and cylindrical pressure vessels. Now for our purposes, we're going to select combined loading, and that'll bring us to this screen. And we're going to select non-circular cross-section, and then select case, circular, non-circular. So we're going to look at shear in the X direction first. Once again, we have our R and F vector that we're going to be used to input into the program. So our components of R are 0 inches in the I direction, 0 inches in the J direction, and 2 inches in the K direction. As for F, we have 0 pounds in the I direction, minus 30 pounds in the J direction, and 40 pounds in the K direction. We then press Accept Input, and that'll bring us to the next part of the problem. So it calculates the moments at the cut and shows that we have a 60 pound-inch, based on our units, moment at the cut around the X direction. We have a 0 pound-inch moment about the Y direction and a 0 pound-inch moment about the Z direction. Now we can click FX Shear and then click Analyze to bring up the next box. Now this box asks you to determine which axis is the neutral axis when dealing with shear in the X direction. So it asks for either the x-axis or the y-axis, and which points there's zero stress at. Now, if I were to choose incorrectly by saying the x-axis and zero stress at C and D, and hit check, it'll tell me incorrect, and will not let me progress any further. However, if I were to, say, click y-axis, zero stress at A and B, and then hit check, it would say correct, and then it would bring up the box to the top right here. Now this is setting me up to be able to solve for VQ over IT to figure out the shear stress in the X direction. But before I can do this, I need to determine the section properties, Q and I, for our particular section. Now, some other things to notice before we get into solving for the section properties. The two boxes you see at the bottom are additional windows that will pop up when you start the solution. The bottom left box is a summary box that will keep track of all the different stresses as you go through the solution to the problem. The bottom right box is a little help box that will change throughout the solutions depending on what you're solving for. So since we're solving for the FX shear, it's just reminding us that the T in the VQ over IT is the thickness at axis CD, and Q and I need to be calculated about axis CD as well. So now that we've pressed the Section Properties tab, we see this screen. So using this, we're able to calculate the section properties for an L section, a C section, a rectangular section, a circular section, an I section, or a T section. For our purposes, we're going to select I section, and then we're going to press Go. That'll bring up this screen on the left where you can input all the dimensions for your cross-section. Our cross-section is shown on the right, and once we have input the flange height and thickness, as well as the web height and thickness, into the W1, W2, W3, H1, H2, and H3 boxes, you can press Calculate and it will calculate the moment of inertias, the first moment of area, the thicknesses, the area, and critical distances. So once that is done, you'll see this screen for this particular problem. Now, to correspond with the axes we've chosen, IAA will correspond to IY, and IBB will correspond to IX. Now, this is similar for Q, and if at this point you're wondering what the critical distances are, you can actually press the Help button, shown here, and that'll bring up another screen where it explains the critical distances. And these are the distances to the outside edges. So D1 and D2 correspond to the critical distances for AA, the line AA, and that's the maximum distance to the edge of the cross section. And a similar nature for BB. Now that we've determined the section properties, we can now determine the shear stress in the x direction. So, as you can see in the top right corner, we have now entered in our section properties, Q, I, and T. We can then press the Accept Input button, which will allow us to enter in the magnitude of stress. Now, since the Fx force was 0, the shear stress will also be 0. So we would enter in 0 and press Check. That would bring up a correct message that you see next to the input box. In addition, if you look at the stresses box in the bottom of the screen here, you'll see that it has been updated with the answer. Now that we've taken a look at the shear in the x direction, we can look at the shear in the y direction. So as you see here, the windows are mostly the same, however this time it's asking for the shear due to Fy and what the neutral axis is for this. For this we're going to select the x-axis, A to B, and we're going to say 0 stress at C and D. When we hit check, we find that this is the correct selection, and we move on to inputting the section properties. Now the box in the bottom right, our little help box, tells us that T will be the thickness at axis AB, and Q and I need to be calculated about axis AB. Using what we know from our section properties from before, we can input those into the box for Q, I, and T, and hit Accept Input. Once we do that, the box below will ask for the magnitude of stress. Now for the purposes of showing how it works when you put an incorrect answer in, I've put 10 psi as my magnitude of stress. Now this is incorrect, so when you hit check, it tells you incorrect. Now, if you were to input the correct answer, which for this problem is 51.0448 psi, you get the correct message. Now once this is done, the stress box in the bottom left will update with the answer. And now we can move on to the next portion of the problem. The next thing we're going to look at is axial stress. So we select FC Axial and hit Analyze, and that brings up the two boxes on the right. Now the first thing we do is enter in the area of the exposed face of the cross section, 0.4375 inches squared, and then hit Accept Input. The next thing we do is enter in the magnitude of the stress, which for this problem is 91.42 psi, and then hit check. It'll tell us correct, and it will update our answers box with the axial stress. We're now going to take a look at the bending stresses. We're going to start with the bending stress about the x-axis. So we select MX bending and click Analyze, and then we need to answer for bending due to MX, what is the neutral axis and where is there 0 stress. So for this, the neutral axis is the x-axis, A to B, and 0 stress will be located at A and B. When we hit check, we find that this is correct, and it brings up the boxes on the right. Now if we look at our help box, it's telling us that D is the distance of C or D from axis AB, and we need to calculate I about axis AB. Using that information, we can input the correct section properties into the boxes, so I and D as 0.5 inches, and then we can hit Accept Input, and then we can enter in the magnitude of the stress. Now the correct answer for this particular problem is 1375 psi. When we hit check, it'll say correct, and with all the others, it will input that into the stresses box, as you see there. Finally, we're going to take a look at bending stress about the y-axis. So we click MY bending and click Analyze, and it brings up the box just below that. It asks for bending due to MY, which is the neutral axis. For this, we select the y-axis, CD, and 0 stress at C and D. When we hit check, it tells us correct, and brings up the boxes in the window to the right. Now, if we look at our help box in the bottom right of this screen, you see that d is the distance of A or B from axis CD, and we need to calculate I about axis CD. So, knowing that, we can input the correct section properties I and D, and click Accept Input. Next, we can enter in the magnitude of stress, and since my is 0, the correct answer is 0 psi. Now, we have the answers for the bending stress about the y-axis inputted into the stresses box. The last thing we're going to do for this problem is review the stresses we've determined. So, if we look at our stresses box, it holds all of the answers we found previously. So to start, our Fx shear stress was 0 psi, our Fy shear stress was minus 51 psi, our axial stress was 91 psi, our bending stress about the x-axis was 1375 psi, and finally our bending stress about the y-axis was 0 psi. Now remember, all units are in psi based on the inputs we provided. The final answers will be in whatever units you've used, so it's good to keep track of what units you've used for measurements, for forces, and all of those things to make sure that when you get to the end of the problem, you have the correct answer.